Thanks for the invitations for this talk, and I will bring you to something is what we invent in Hong Kong, and then bring it to the clinical usage. Different from the from Dennis Low, this is marvelous, so we are just at the beginning, and then we are also just learning how to do that. So actually, I will tell you about the story of the Hand of Hope. This is what we invent in the Hong Kong, and then what we have put forward. And then I'm from the Chinese biomedical engineering. So biomedical engineering actually is we integrate the medicines, biology, engineering all together. So it's a mixture. So virtually, we need to learn everything. And in the BME, actually, we have biomaterials, regenerative medicines, biomoleculars, imaging, and also we can build robots and sensors. And how can we achieve all this research in Hong Kong? Actually, it's slightly fortunate than Dennis maybe. So we got some funding from the GRF. So we have some basic research. And then recently, we also have this ITF fund, and actually our robot hands is built by the ITF fund. And then so that's what is happens. And also I have the whole team with me. But first, we have the objective. What we want to do if we have all this funding is in Hong Kong, if you go to a hospital, we can see a lot of stroke patients suffer. They need a lot of rehabilitations. They have suffer, and their family also suffer. So how to make the survivals getting better? So normally they have this hemiplegia, and then so the hand and the leg cannot move, as they want. So can they help them to move their hands and walk better? This is our aim. So we have the physiotherapists, occupational therapists, but can we do it better with the robotics? So this is what we built. And then actually, recently, we also get the Jockey Club support our technology to launch in the community. So Jockey Club is very generous. They have these 3-year programs. They help us to launch our technology that built in our lab to 40 centers in Hong Kong. So it's in Hong Kong, everywhere, no matter in Hong Kong Islands and New Territories or Kowloon side, actually, you have different centers can use those technology. So include the Hand of Hopes for the hand movements training, exoskeleton for the ankle robots for walking, stair, and also some of the cycling device for the cognitive training. So today, I will look at the Hand of Hopes. So when we start, actually, this is also our study in our lab. So we are not just build robot, we also study the animal. So we make the stroke rat, okay, make the rat become stroke. Then we look at the literature, look at the other people. They say it's training the rat to run is good after stroke, So we do the same things. We train the rat to run after that, And then we dissect the rat, and then see what's the rat will be happening. So what we see, the white color on the screen is the infant volume from the brain. So we train the rats after 7 days, and then we look at the dissections of the brain tissues. Then what we got is a surprise. The infant volume is bigger, then we don't train the rat. But then we look at the function of the rat, they perform better. So what's happening? They can perform better in the functions, but they have more brain damage in the brain. Then we think about, can we do better than this? The brain tissue didn't damage, but at the same time can recover better. Then we look at the patients, then we look at our training, and we figure out one thing, okay, can we do something is the rat like to do? So they would like to do exercise, at the same time don't damage the brain. Before, we just use the treadmill to train the rat, to force the rat to run. So how to encourage the rat to run by themselves? So what should we do? Give some food, but actually after stroke, they don't like to eat, okay? So what else we can do? Actually, the rat like to run in the wheel, just like the pet. So we just design the wheel. That's it, the rat like to run, they can run anytime, and then we do that. So we just give the wheel, and then the rat run on it, and then what's happening? Then we look at the data, the top line actually is the ones the rat run on the wheel, okay? So it's what we need to do, give the training the rat like to do, and then they have better functions, and also the brain damage have been reduced. Then we also look at why is it cause this phenomenon. So we look at the neurotrophic factors. So we call the BDNF. So we see the hippocampus have a huge increase in the real training. Then on the other side, we look at this stress level. We find it is, okay, the treadmill training, really stressful. But the real training is very good. So we realize if we can build the robots that help the patients to willing to do a training, to bring like it, then this is the best training. Not the treadmill training, not the robots that force the patients to walk or use the hands. Then we look at the designs, and then you can see on the screens, we come a long way, from the earlier 2008, and then we use the German systems. We build our own. At that time, I was in PolyU. We call this PolyJBot, and then we build the hand of hopes, and now we have different designs, and even the 3D printing robot hands. So what's the design look like? How to motivate the patient to move? We detect what the patient want to do. So after the hand has been paralyzed, we still can detect some signal from the muscle, from the brain. Then we use it to drive the robot. So the robot is not passive. Actually, it's controlled by the humans, just like the Iron Man. No, they want to move, they will move. Okay, if the patient don't want to move or move in the wrong way, actually the robot will not do any actions. Then we prove it into the clinical settings. So we build a robot, big tower, and then we prove it. So it's on the first paragraph, you can see, if we have this robot together with the intention from the humans, actually we have better recovery. Clinically, we prove it. And the other groups is we just use the robot to do this passive training. We believe it saves a lot of time for the therapist, but actually it doesn't help the patient to recover. We have this 3 months follow-up. After training, we find this no effect. So bring interactions with the robot, it will help the stroke recovery. Then at that time, you always think about, okay, we have this big robot, but the patient still not happy with our robot because we cannot train the hand and the wrist. When we look around at that time, no good designs in the world, then what we can do? Build our own, okay? So this is the one, we got the ITF and build it. And then, so how it works? Actually, we have different mechanical designs together with our high amplifier in the electronics can detect the muscle signals. Then the good news is we prove this is successful, and then we actually launch it and commercialize it and license to a company called the Robotics in the Science Park. And then now this company have launched this product in 30 countries, and then also get this medical device certificate. And one important thing is the patents. Actually, when we designed this hand of hope, we filed the patents. How to file patents? I learned how to write patents. So one thing is learn how to write patents at the early stage when you are the scientist and the engineer. So actually, I teach the patents in the school, in the university right now. So this is the design, and then you can see we can help the patient to grab different objects, and then the robot hand is actually controlled by the intentions. So this is the patients. We can see. Let's see if I can put it on. So this is how the patients use their own hands, cannot grab the spongy, also cannot release it. But use the robot hands, she use the intention from the muscles, and then she can grab and release it. This is for training, to train the brain. So after training, what's happening? We can pick off the robot hand because the brain already learned how to use the hand again. So we can show you this video. The lower part is the patient hands. So very difficult to do this lateral pinch. After 20 sessions of training, around 1.5 months, so you can do that by herself with the robotic. And then 3 months later, the brain just learn it and then keep doing that. So this is, we can see how we integrate the things together. So if we can do it in the earlier stroke, like this ones, the left side is affected. Okay, very poor. After 10 sessions of training, around 20 minutes in the hospital, much better. Then after 20 sessions. So if you are a rehab doctor, you have physicians, and PTOT, they notice there's something they haven't seen it in the hospital before. Then we run the clinical trial. Definitely, we see the dramatic effect in the hand functions and recovery. So nowadays, there's a lot of people start to invent different robot hands, and then for the stroke rehabilitation. So actually, we can, from the from the lab, and then actually we can bring the technology to the whole world, and then to see how the training can be different from the previous. So now what we can do is we can use the brainwave. So we decode the brainwave and then to control the robot hands. So we can use the AI or the technology. We can do that. So let's see. So this is the EEG signal, electroencephalogram. We can also, from the MRI, we can see how the brain learn all these tasks and technique. And after the robot hand training, actually we can see how the brain have learned all these new tasks. And then this is some of the recent study. We see the motor area have been changed to other area, maybe on the affected side, but just near to the lesions. And then they can pick up the whole task again. That region maybe originally is for the leg, but now they use it to control the hand. Okay, so the brain is very plastic. They can learn different new tasks. So this is some more experiments. We can see how the brain have been learned, and then we adapt to the new world. So that's why I want to share with you. This is my robot hand. If you have time, please come and see it. Okay, thank you very much.